Hi everybody, this is section 4.3. I do realize that we're going backwards in the book, but in order to do chapter 9, which is systems of equations, 3 equations with 3 variables, we really have to understand how to do systems of equations with 2 variables in 2 equations. So that's kind of why I'm going backwards a little bit. I've only got 5 questions here, so it's just some practice. This should be a review from elementary algebra. It's really going to help us. And what else did I want to say about it? Oh, there's 3 different ways that we can solve systems. We can do it graphically, we can use the elimination method, and the substitution method. And I've just chosen randomly to concentrate on the elimination method just because generally you use it a little bit more than the substitution method. And we'll be using that more in chapter 9. So what do we have here? We have a system of equations. What does that mean? Well, that means I've got 2 variables. I've got an x and a y, and an x and a y. And these things have to work, okay, the answers, an x and a y has to work, which means it has to make a true statement in both of these at the same time, okay? So I have to find an x and a y that makes this particular one true, and the same x and y that makes this particular one true as well. Okay? So, elimination method says, first of all, you write down your equations and you want to stack them. Okay, stacking means that you want to put your x terms on top of each other and you want to put your y terms on top of each other. And then you want to put just your numbers on top of each other, okay? Now, I can do anything I want to an equation, but I can also do anything I want to 2 equations. So what I'm going to do is I'm going to randomly add these. Okay, I'm going to add these 2 equations. My goal here is to drop one of the variables. So x minus x drops, so I don't have any x's. I'm adding, so 3y plus 3y is 6y, and 16 plus 2 is 18. Do you see how my goal here is to get these to drop? And they did when I added them. I'm solving, so I'm going to divide through by 6, and so y is 3. Okay, there's one answer. I need an x and a y. Now what I'm going to do is I'm going to go back to either one of my 2 original equations. It does not matter which one. Okay, I'm just going to randomly pick the top one. I'm going to rewrite it. And we've got this solution. Y is 3. So I'm going to put the 3 in right here. Because that's what you just told me y was. Or at least I told myself that's what y was. Okay, y is 3. See how now I've eliminated this double variable and I've got a single variable? That's really nice. 3 times 3 is 9. Then I subtract my 9 across. This is gone. 16 minus 9 is 7. Okay? There's my x and there's my y. We can put them in as an ordered pair. Sometimes we like to do that. We always put the x first, then the y. Okay? Now what we need to do is we need to check to see if we've got these right. So we're going to take the first equation. We're going to see if that makes a true statement. Okay, x here is 7. Y is 3. So 7 plus 9 is 16. Is that a true statement? Yes, it is. This side is 16, this side is 16. True. Okay? Try the other one. Now remember, it has to work for both. So we write down the original equation. I'm going to substitute my 7 in here. I've got a negative 7 then because it says the opposite sign. Plus 3 times y is 3 is equal to 2. Negative 7 plus 3 times 3 is 9 is equal to 2. Negative 7 and a positive 9 is a 2. So it works out here as well. Okay, so it works out here and it works out here. So we have our solution. You're supposed to type an ordered pair in here. So we'll just click on this, and we'll do 7 and a 3. And check our answer. Well done. That's my dog. If you can hear that, that's my dog whining. Don't you just love it when dogs whine? Hello, Mr. Bear. I'll have to show you a picture of my dog sometime. I have 2 big St. Bernards. Well, one's big, one's a puppy. So, all right, let's go on to another one. All right, we're going to try that again. I might have to pause this and go put him away. I'm going to drive everybody crazy. But you know what? If I can get driven crazy, you can get driven crazy. Yes. All right. Stack A's, B's, numbers. If I were to add these, I can see that my A terms are going to drop. So that's what I'm going to do. It doesn't matter if you drop your A's or your B's. Makes no difference whatsoever. 6A minus 6A, gone. So all I have left, this is like a 1B. 9 B's and 1 B is 10 B's. Then I have a negative 45 and a positive 55. So what would that be? Well, that's 10. Right? Divide through by 10, divide through by 10. So B is 1. Half done. I'm going to go back into either one. I'm just going to go into this one just because I picked the first one last time. And I'm going to rewrite my original. And I'm going to insert this here because you told me B was 1. Okay, subtract a 1 across, gone, minus 6A is equal to 54. Okay, so far so good. All right, and our last piece of the puzzle here is to divide through by negative 6, divide through by negative 6. So this is gone. So A is equal to 54 divided by negative 6 is a negative 9. So we've got our 2 solutions here. Okay? So in your homework, before a test or anything like that, you're going to want to plug them in to check them. And then you know you've got them correct. All right? I don't think I assigned any of these. And that's not the point to this. So I don't know that we'll have any of these on our homework. All right, so what happens if your variables don't drop? Now here's U's and V's are hard to distinguish, so you can use X's and Y's if you want to switch them. I usually like to make my V's curvy like that, so I can tell a U from a V. Okay, so if I added these, my V's would not drop and my U's would not drop. I'd have 8 U's or I'd have 3 V's. Okay, so what do you do then? Well, we can, like I said in the very beginning, we can do whatever we want to either one of these equations as long as we do the same thing to every single term. Remember that? So my goal is to pick a letter to rid. I'm just going to randomly pick V to rid. Okay, I just want to get rid of V, just randomly. My goal is to get the coefficients or the numbers in front of the V to be the same number, opposite signs. So if this is a 2, I want to get this one into a negative 2. All right, how do I do that? Well, I would multiply each term by negative 2. Okay, so this becomes negative 6 U's, okay, minus 2 V's is equal to a positive 12. Now this equation here and this equation here are exactly the same. This one's just twice as big, negative twice as big, actually. And so now I'm going to write the other one underneath because it doesn't matter what order we put things in. But I'm still going to stack. I'm going to add. I've got a negative 6 and a 5 for a negative U. Negative 2 and a positive 2 is gone. That was my goal. 12 minus 15 is a negative 3. I'm going to finish it up by dividing through by negative 1. This cancels, so we have U is 3. All right? Now I'm going to put that in, let's just put it here. Doesn't matter. 3 times 3 plus v is negative 6. 3 times 3 is 9, plus v is negative 6. I subtract my 9 across. 9 minus 9 is gone, so I have v is a negative 15. So we've got u is 3 and v is a negative 15. So let's try this. I should be trying all of these because I could be doing some of these wrong and then I can't catch them if I don't check my answers. So, all right, let's try another one. Well, I'm going to let you alone on this one. You could either multiply this top row by a 6 every single term. That would make this term into a negative 6y, and these would cancel. Or you could multiply this entire row by a negative 3 each term. That would make this term negative 3x, and these would cancel. Doesn't matter. Makes no difference whatsoever. I'm hoping that this one doesn't look like that. Let's see what it looks like here. Yep, good. All right, so this one's a little tougher because I look at this and there's nothing that I could ever multiply just one row by to make it into a 7 or a 4. So here we have to do it twice to both rows. Okay, so randomly pick a variable to get rid of. I'm just going to pick y's. All right, I have to turn a 7 and a 3 into the same number, opposite signs. I picked the y's because they already are opposite signs, so I don't have to worry about that one. But I have to turn them into the same number, so I'm going to look for the LCD. The LCD between a 7 and a 3, what is the lowest number that a 7 and a 3 both divide into evenly, is a 21. So in order to make this into a negative 21, I have to multiply every term by 3. So 4 times 3x minus 7 times 3y. Remember, the order of multiplication doesn't matter. 26 times 3. I've expanded this 3 times as big. Now I want to make this into a positive 21, so I would multiply it by 7. So therefore everything gets multiplied by 7. X plus 3 times 7. Y is 3 times 7. Okay, that's this one. 7 times is large. So here we have 12x, that's 4 times 3, minus 21y's, and what is 26 times 3? Let's be lazy. 78 is equal to 78. So what we're doing is we're just cleaning it up. 3 times 7 is 21x. 3 times 7 is 21y. 3 times 7 is 21. See, now if I add these go away. A negative 21 plus a 21 is gone. I've rid my y's. 12 and 21 is 33. 78 and 21 is 99. Then I would divide through by 33, and x is 3. There's one answer. Now what I'm going to do is I'm going to go back to one of any equation. I can go back to this one, or 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 this one, and put my x is equal to 3. I'm just going to choose the simplest one to put it into, which I think maybe is this one. Doesn't really matter where you put it. But x is 3, so I'm going to crunch the numbers here. 3 times 3 is 9. I subtract my 9 across. This is gone. So I've got 3y is equal to 3 minus 9 is minus 6. Divide through by 3. These cancel. So y is negative 2. Ordered pair, 3 3, negative 2. Now I could check them manually by putting them in here, right? Or I can be lazy and let the computer check them. Lazy, 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 lazy. Excellent. Now, obviously, in a testing situation, you're not going to want to take the chance. You're going to want to put them in here. And it has to work for both of these. It has to make true statements for both. And there's only going to be one answer because I didn't assign any of these infinitely many solutions or no solutions. So when you check them and it's working for both, you're guaranteed it's the right answer. Okay? And that was short and sweet. I love it. 15 minutes. So practice these, and then we'll come back and work on chapter 9, which we're going to include the third variable of a z, right, and the third equation. And then we'll look at some choices there. Okay? See you later.